Today we're going to talk about solving equations when you have variables on both sides. This is our fifth and final step in solving equations this year. In future years you may have more, but for us we're going to stop with a total of 5. Our new step is, do you have variables on both sides of the equation? If your answer is yes, you're going to work to get all variables to one side, and we're going to do that by adding or subtracting. If the answer is no, you simply go on to the next step. We can say we're going on to the next step because it's not actually our fifth and final step, it's our third step in a series of 5. So we're going to start with step 1, which is there any distribution to be done? Step 2 is combining like terms. Remember, that's just the left-hand side versus the right-hand side. Step 3 now is going to be getting all variables to one side of your equation. Step 4 is to add or subtract your constant, which is the number without a variable attached. And finally, dividing or multiplying sometimes by your coefficient, which is the number in front of your variable. We always want to remember this 6th step, which is to check your solution by substitution. You always want to plug your answer back into your original equation to make sure that it's right, even if you do it in your head. So here's our first example. We have 9x equals x plus 16. Every time you solve an equation, you need to go through all 5 steps to see what needs to be done in which order. So for instance, I would ask myself, is there any distribution that needs to be done? The answer is no, since I don't have any parentheses, so I just go on to the next step. Do I have any like terms that need to be combined? And I'm asking myself this question on the left-hand side of the equation, and since I don't have any like terms there, I go straight to the right-hand side of the equation. Do I have any like terms here that need to be combined? Since my answer is no on step 2, I go straight to, do I have variables on both sides of my equation? Our answer is yes, of course. I have a 9x on the left and a 1x on the right. I'm going to get rid of one of these two variables, and I usually recommend that you get rid of the one on the right. So since I have 1x there, I'm going to subtract that x from both sides, of course. Now these x's are gone, they cancel. I'm left with 8 x's on the left, and it equals a positive 16 on the right. My fourth step is to get rid of any constants. Since I don't have anything being added or subtracted from my variable, I move on to my very last step, which is to divide by my coefficient. My 8's cancel, and I'm left with x equals 2. Here's my answer, but I need to be 100% sure that this is the right answer. So I'm going to come back up to my original equation and I'm going to plug it in. Again, even if you just do it in your head, you still need to make sure that it's right. So on the left-hand side, I get 9x, which is now 9 times 2. That gives me 18. On the right-hand side of my equation, I get x plus 16, which is 2 plus 16. Again, I get 18. If the two sides are equal, I know I'm okay, and I can move on to my next equation. Here we've got 4y minus 70 equals 12y plus 2. Again, I'm going to go through all 5 steps. Do I have any distribution that needs to be done? No, we don't, so we move on to step number 2. Do I have like terms that need to be combined? Do I have like terms on the left-hand side of my equation? No. Do I have like terms on the right-hand side of my equation? No. If there were, I'd want to combine them. For now, I go into step 3 and say, do I have variables on both sides? Yes, I do. I have a 4y and a 12y. So I'm going to subtract 12 y's from both sides. It really doesn't matter which set of y's you're going to take away. We just need to make sure to do it to both sides. These 12 y's cancel, and I'm left with negative 8 y's minus 70 equals this positive 2. Step 4 is to get rid of your constant. Here's our minus 70, so we're going to add 70 to both sides. These will cancel, and I get negative 8, if it'll write, y equals 72. And of course, my last step is to divide by my coefficient to get rid of my negative 8, and I get y equals negative 9. Remember to go back up and double check that your answer is the right one. On the left hand side, I would get 4 times negative 9, which is negative 36. Subtract another 70. That would give me negative 106. On the right hand side, I would get 12 times negative 9, which is negative 108. And I still have to add 2 to that. Negative 108 plus 2, again, gives me negative 106. Since both sides are equal, I know I'm okay to move on. Next, we have 5 times quantity, p plus 6, equals 8p. Again, we start with step number 1. Is there any distribution that needs to be done? Our answer is yes this time, and after I do my distribution, it looks like 5p plus 30 equals 8p. Step 2 says, do I have variables on both sides? That was step 2 was, do I have like terms? Sorry about that. Since I don't have like terms on the left or on the right, I'm good to go to step 3, which now is, do I have variables on both sides? Sorry about the mix-up. My answer is absolutely yes, so I need to get rid of one set. This time I'm going to get rid of the 5 p's from my left-hand side. I'm going to subtract them from both sides, and those cancel. Now I have a positive 30 and a 3p. I don't have any constants to add or subtract, so I go straight to dividing by my coefficient. Those cancel, and now I'm left with p equals 30 divided by 3 gives me 10. P equals 10 would be my answer. I want to make sure that I'm right though, so I'm going to come back up here and just double check. I have 5 times 10, which is 50, and 5 times 6, which is 30. That gives me a total of 80 on the left-hand side. On the right-hand side, 8 times 10 also gives me 80. Since both sides are equal, I'm ready to move on. And last but not least, this is an equation similar to what I showed you at the very beginning of the equations unit, where everyone flipped out and said there's no way we'll be able to solve this type of equation. But I'm going to show you how simple it is when we have our 5 steps. Step 1, remember, is do we have any distribution that needs to be done? Since we have parentheses, our answer has to be yes. So I'm going to multiply 2 through my parentheses, giving me 6x minus 8. Don't forget to write everything else down. Plus 5x equals 3x plus 16. Step 2 is combining like terms. On the left hand side, you can see that we have a 6x and we're adding 5 more x's, giving me a total of 11 x's on the left hand side. I still need to write down everything that I haven't used yet. Step 3 says, do I have variables on both sides of my equation? And absolutely I do. So I'm going to take away these 3 x's from both sides. These 3 x's are gone now. 11 x's minus 3 of those x's leaves me with 8 x's. I still have a minus 8, still have an equal sign, and I still have a positive 16 on the other side. Now I need to get rid of my constant, the number without the variable, so I'm going to add it to both sides. Since we always do the opposite, I get 8x equals 24. And when I divide by my coefficient of 8, I get x equals 3. Again, I'm just going to make extra sure that I have the right answer. Up here, when I put 3 in for x, I get 3 times 3 is 9. 5 times 3 is 15. And 3 times 3 is 9. Over here, I get 9 minus 4, this is 5. Times it by 2, I get 10. And 10 plus 15, this side gives me a total of 25. On the other side, when I add 9 and 16 together, I also get 25. Now that I know the two sides are equal, I know that I'm right and I can move on. It's amazing how breaking down an equation into 5 different steps can make an equation simpler, or easier, I should say, to solve. Remember to write down any questions so that you can ask me during class. Your assignment today is the Equations with Variables on Both Sides worksheet. Remember, it'll be on my website and on Skyward, ready for you to print.